Okay, so now we're going to take what we've learned about oxidation numbers and we're going to put them together in some information about reactions that are redox reactions and what happens in a redox reaction. So in a redox reaction, the oxidation numbers of the elements that are present are going to change because they're transferring electrons. Now let's remember, electrons have a -1 charge. So that is really important to remember because that really messes people up a lot. It is a -1 charge. And so if I add electrons or if I lose electrons, it's going to change it. So if I have oxidation, and that is a definition, it's an important definition. Oxidation is the loss of electrons, meaning if I'm losing electrons, let's use my example from before. Aluminum, which is an element, has an oxidation number of 0, turning into Al3+, going from 0 to +3 means it lost 3 electrons. Because if I put 3 electrons here, 3 times -1, +3 ends up to a charge of 0. Okay, so it's losing electrons is oxidation. Reduction, on the other hand, is gaining electrons. And let me use my example from before. I had Cu2+, changing into Cu, which is an element, has a charge of 0. So it must have gained 2 electrons, because -2 and +2 adds up to 0. So gaining electrons is reduction. Again, important definition. And if you notice, oxidation, the oxidation number increases. It went from 0 to +3. In reduction, it went from +2 down to 0. It got smaller, it got more negative, if you will. Close, think of a number line when you're doing this. So in order to conserve charge, the electrons gained must equal the electrons lost. And we're going to talk about how to balance redox reactions later. For right now, we're just going to identify which one has been reduced or oxidized. So first of all, in order to do that, you have to find the oxidation numbers, like we just did, of every element present. Okay, you have to look at the numbers that they have, and you have to be able to do that properly. Okay, you're going to compare the oxidation numbers before and after the arrow. Okay, after the reaction. If the oxidation number for an element increases, that substance was oxidized. If the oxidation number decreases, that substance was reduced. And it is possible that something doesn't happen to one of your reactants. I mean, it doesn't get reduced and it doesn't get oxidized. It's possible. It's a spectator ion in that case. But the big thing is, there can only be one substance that is oxidized and only be one substance that is reduced. You cannot have something gain electrons and have something else gain electrons too. Something's got to lose them to give them up. Okay, so you can only have one of each, and it is possible that when you look at a reaction that something doesn't get reduced or oxidized. Typically that's going to be things like water, although not always. So it says identify the substance oxidized, the substance reduced, and we're going to write the half reactions, and I'll show you how to do that for oxidation and reduction. So if I'm looking at this, I see Mg turning into Mg2+. That is half of the reaction. That's called a half reaction. And then I have Cu2+ turning into Cu. Okay, those are the half reactions. So that's how you do it. You split it based on what happens to the various different things. Okay? And you just literally rewrite it. Mg on the left, Cu2+ on the left, Mg2+ on the right, and Cu on the right. And then you have to identify which one's been reduced or oxidized. So if I'm looking at Mg, I see an element in its standard state. It went from 0 to +2. Its oxidation number increased, therefore it was oxidized. And this went from +2 to 0. Its oxidation number decreased, therefore it was reduced. And that's how you write half reactions. All you have to do is figure out the oxidation numbers and go from there. Okay, so let's look at this one. Oops, let's get rid of that 3. Okay. I'm going to write the half reactions. Ag1+ goes to Ag. Fe goes to Fe3+. So if I look at those, Ag1+ going to Ag, element in its standard state, oxidation number went down, it was reduced. Fe, element in its standard state, goes to Fe3+, oxidation number increases, it was oxidized. And that's all you really have to look at. We're not going to talk about balancing them just yet. Okay, now this one's a little bit harder. Got a lot of crap going on in here. So I'm going to ignore the coefficients because coefficients really aren't important. That helps balancing, and we'll talk about how to balance later. So what I have here is have Na going to Na plus. Okay, and notice I copied that 1 plus down. I didn't copy it on this side because it wasn't there. I have H1 plus turning into H2O. And then the last one I have a Cr2O7 2 minus turning into Cr3 plus. And again, I'm going to ignore the coefficients. So all I have to do is look at the different things and identify what their oxidation numbers are. Element in its standard state is 0. Went from 0 to +1. Oxidation number went up. It was oxidized. Now remember, I can only have one of each. So one of these guys has to go away. So let's figure out what that is. H1 plus, over here, hydrogen has a 1, and oxygen has a -2. So the H didn't change, did it? So nothing. This was not reduced, and it was not oxidized. It's not important. Let's look inside here. Obviously it's been reduced, but let's figure out a way to prove that. Okay? So, I don't know what Cr is. X. There are 2 of them. Plus 7. I'm going to do it down below. 2x plus 7 times -2 has to equal the charge on the ion, -2. Got 2x minus 14 equals -2. X is therefore +6. So it went from being +6 to +3. It went down, therefore it was reduced. Okay, so I'm going to erase the ink. So this was oxidized, and this was reduced. This didn't do anything. Okay, it didn't change at all. So it's not oxidized or reduced. All right, take a minute, see if you can do this one. Again, ignore the coefficients. Break them apart into the half reactions. Make sure you copy correctly. MnO4 1 minus goes to Mn2 plus. Fe2 plus goes to Fe3 plus. And again, I'm ignoring the coefficients. H1 plus goes to H2O. And again, one of these is going to have to go away. You probably already have figured out which one that is. That's okay. We're just going to go through and prove it. Inside here, you have X for the Mn plus 4 times -2 equals -1. X minus 8 equals -1. This is +7. So it went from +7 down to +2. Oxidation number went down. It was reduced. Fe2 plus to Fe3 plus, the numbers are right there. You don't even have to figure them out when they're monatomic ions. The oxidation number went up. It was oxidized. Therefore, this one probably went away, and you recognize it from the previous one. 1 plus in there, 2 minus here. Nothing happened to that one. So in terms of this was reduced, this was oxidized, this didn't do anything. Okay? And that's really all you have to do. So you have to be able to do those oxidation numbers. Some of them are a little bit harder than others. That was a hard one. This was a relatively easy one. But it's basically all you have to do is look at the numbers and see if they increase or decrease to determine if they've been oxidized or reduced.